Let's pick up right from where we left off at the end of the last demo. There we had constructed a very elegant scatterplot which had two continuous variables along the x and y axes, then a third variable used to color code the points, and a fourth variable used to determine the area of each circle. Let's build one more scatterplot, and this one is going to have the color of each of the points taken from the fuel type of the corresponding car. And that's why we have repopulated our color column, and the code for this is on screen now. Let's focus first on the right hand side of the equal to sign. There we index into our car data and extract the fuel type column. This is a panda series representing just one column. We invoke the apply method on this series, and that apply takes in a lambda. That lambda is pretty simple. If the fuel type was gas, then the color is set to green, otherwise the color is set to orange. This lambda is going to be applied one row at a time to the fuel type, and x is going to take the value of the corresponding fuel type. All of these green or orange values are going to be used to populate the color column in our car data. That's on the left hand side of the equal to sign. And then we just examine the fuel type and the color and invoke the sample method. This convinces us that we do indeed have fuel types and colors associated with each other. Wherever the fuel type is gas, the color is green. In the one instance where the fuel type is diesel, the color is orange. We now have the color of the individual points sorted. It's time to figure out the radius. This time we are going to make use of another column which we've added to our car data called size. Size is a function of the cylinder number. That size depends on the value of the number of cylinders, and that mapping is applied using the .apply method and a lambda passed in. This lambda returns different values based on the number of cylinders. If the number of cylinders is 12, then size is set to 3000. If it's 8, it's set to 2500, and so on. And if we do not have the specific number of cylinders that we were expecting, we just return a size of 500. Once we have the size, we divide this by 500 in order to get the scaled size. And that scaled size is going to provide the radius for the circles in our scatter plot. And at the end of this all, we sample this data, and we can see that the size and the scaled size are indeed related in exactly the fashion we defined up above. Size divided by 500 gives us the scaled size. Once again, we are ready to compute our scatter plot. This is the code for that scatter plot, but it'll probably make more sense if we first understand the output.